Hello friends, welcome back. So we were discussing insertion in red-black trees in my previous video, and we were continuing with this example in which I was demonstrating how to create a red-black tree from scratch and how to insert every element one by one. So in case you haven't watched my previous videos, you can please find the link in the description. And I'll tell you that we stopped in the last video at this position where I inserted nodes 9, 17, 6 and 14. So let me give you the glimpse of the tree constructed till date when I inserted 9 and when I inserted 17, 6 and finally I inserted sorry finally I inserted node 14. So this was the configuration which we obtained till the insertion of node 14. Alright. And for the reference purposes, all the rules for insertion are already mentioned on the top right side. So we checked, I'm just giving a previous revision that when we inserted node 14, we, observed a violation and then we checked the color of the uncle. Now let us start with insertion of node 15. Now when we insert 15, again with the properties of the binary search tree, we know that 15 is greater than 14. So we will insert 15 towards the right side of node 14. Now what happens? If the parent of a new node is red, so parent of a new node is red. Now guys, when does parent of a newly inserted node is red? Definitely that means the parent is not root because root cannot be red. Root is always supposed to be black in color as per the properties of the red-black tree. So, definitely we know that this particular situation, the moment we insert 15, we will insert 15 and we will color it as red. Why? Because the tree is non-empty, and whenever a tree is non-empty, the newly inserted node will be inserted as a leaf node and we will have to color it as red. So the moment we inserted 15 towards the right side of 14, there was a violation that no two adjacent reds can be allowed in a red-black tree. Fine. Now come to property number 4, rule number 4. If the parent of a newly inserted node is red, then check the color of the parent sibling, that is, check the color of the uncle. Now, we need to focus on certain important parameters. 14 is the parent of 15. So, parent of 15 is equals to 14. Alright. And uncle of 15. Who is uncle of 15? Right now, at this particular position, what do we have? We actually have the null nodes, right? Or we have the sentinel nodes. So we will go with the first part of rule number 4, that if the parent of a new node is red, okay, parent of 15 is 14 and that is red in color. So we need to check the color of parent sibling. That means 14 sibling. So, who is the uncle of 15? That is a null node. Now, do we have any kind of property for null node? If the color is black, the uncle's color, or if it is null, then do appropriate rotation and recoloring. That means now we need to do appropriate rotation and recoloring. Now, I will tell you some tricks also, that how can you fix this type of rotation and recoloring scenarios. All right. Now, guys, this is the situation which we have. So we need to do appropriate rotation and recoloring, and we are complying with the first property of rule number 4. Now just observe over here, we have one configuration that is left, 17 to 14, this path is left, and the path from 14 to 15, this path is right. So we have LR configuration over here. Okay. Whenever we have an LR configuration, the first thing we do is we rotate towards left. So the node which is placed at the right hand side, we rotate it towards left. Alright? And when we rotate it towards left, the scenario which we will get is this scenario. I will make it again for simplification purposes. So this is the scenario which we had, and once we rotate this at the left position, the scenario which we will get is, so we had this left and right. The scenario which we will get is that we'll have 9, 6 and 17, and then we will have 15, and then we will have 14. When we shift 15 towards the left position, node 14 will move down in the same left position. Okay, so first rotation gave us this configuration. All right. Also, let me tell you one thing, that whenever we have an LR configuration, we require two rotations. Alright, so the first rotation is that the rightmost element, that is 15, is shifted towards the left position. That is the first rotation. So we encountered 15 towards the left, above 14, and then 14. And this configuration, I mean, definitely, because 14 is less than 15, so it should be at the left of 15. So it is complying. However, the colors are not appropriate. So that violation needs to be fixed. Now we got the LL configuration. Initially we had the LR configuration. Just observe over here. Initially we had the LR configuration, and now guys, we have, after rotation of node 15 towards the left position, we got the LL configuration. Both the two nodes who are facing violation are at the left position. So whenever we have LL configuration, only single rotation is required. Alright, and whenever we have an LR configuration, two rotations is required. So right now in this case, we had LR rotation, LR configuration. So the first rotation was, we shifted 15 towards the left position. So we got this configuration. And the second rotation is that the middle node, I'm telling you a trick, that the middle node will now act as a root node. The middle node will now act as a root node, and then we will do appropriate coloring. Okay guys, so the middle node will be acting as the root node, and then we will be doing appropriate coloring. Okay, so we will have the final tree as 9, 6, and then we'll be having 15, and then we'll be having 14 and 17. I told you that the middle node will be acting as the root node for these two nodes. These two nodes, it will be acting as a root node, and 14 will be at the left position, and because 17 is greater than 15, so it will come at the right position. So we have this type of configuration over here. So root is black, these two children are black, and over here we have red and red. Okay, and if parent of newly inserted node is black, you can exit. Parent of newly inserted node is black, you can exit. All right, so root is black, and you have, even if the black height we want to see, So if let me just check with respect to the leaf nodes. For instance, if I want to check the black height of node 9, the black height is one black node for 6 and another black node for the left leaf node, so 1 and 2. If I check the another path of left subtree, I have one black node in node 6 and another black node in the right leaf node towards the right leaf node of node 6. So the black height of node 9 is 2 with respect to the left subtree. If I go for the right subtree, one black node, because guys, we will not count the node itself, we will not count 9 itself, okay? So one black node with respect to node 15, and definitely the sentinel nodes or the null nodes of 14 and 17 will also be there. So another black node towards the right leaf node, again 2. And if I go another path with respect to 17, or even if I go with respect to 14 also, so you can see clearly that the number of black nodes is 1 and 2, 1 and 2, 1 and 2, 1 and 2, whatever path we encounter. Alright guys, so in order to see that what happens when we insert node 29 and what kind of configurations we notice, so stay tuned for my next video. Thank you so much.